Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Today on Malaysia to TVET on Research via Exposition 2023, I'm Zulkifli Bin Che Din. I'd like to present a research paper, Multism Software Simulation, Past Position Modulation Design using LM555 IC Timer. I would like to introduce my members. My members are Salmiza binti and Norliza binti Kassim. Abstract. Past position modulation or PPM is a modulation method in between the digital and analog, which can be used to process the digital and analog data transmission. This research aims at presenting the design circuit and simulation of PPM signal. This research also aims at presenting the characteristic of LM555 IC timer, which can operate in two modes, a stable multivibration and monostable multivibration mode. The workability circuit design is confirmed using NI Multisym version 14 software package. The output signal is for given a specification of duty cycle of 70 and 57 with 2 volt peak-to-peak and 1 kHz modulating signal input. NI Multisym version 14 software package as a learning aid during learning and teaching process, capable for the accuracy of the circuit performance. Introduction. Pulse position modulation is the process of changing a binary pulse signal to represent the information to be transmitted. Refer to the book by Louis Frenzel, Principle of Electronic Communication System, 4th edition. There are four basic forms of pulse modulation: pulse amplitude modulation (PAM), pulse width modulation (PWM), pulse position modulation (PPM), and pulse code modulation. In pulse position modulation, the position of each pulse changes according to the instantaneous sample voltage of the modulating signal, while the amplitude and width of the pulse are kept constant. While in pulse width modulation, the width of the pulse is very proportional to the analog amplitude information signal. Both of the pulse and width modulation shown in Figure 1. Figure 1. Pulse width modulation and pulse position modulation signal. Literature review. The purpose of the research is to simulate PPM signal using LM555 IC timer. Multisym software is used to design, analyze, and simulate the PPM circuits. This software provides a virtual environment where the user can create and test circuits without the need for physical components. To achieve PPM signal, two LM555 timer ICs are used, in which one operates in a stable mode and monostable mode, as shown in Figure 2. Figure 2 shows the generation of PPM signal block diagram using LM555 IC. From the concept of a stable multivibrator by M. Abrar, 2017, T height equals to T on equals to 0.9693 Rb times C. T low is equal or T off is equal to 0.9693 Ra plus Rb times C. For T, total T is equal to T on plus T off, or T can be measured by 0.963 RBC plus 0.693 Ra plus Rb times C, or T can be measured by 0.693 times Ra plus 2 Rb times C, and the duty cycle D equals to T on divided by T on plus T off. Duty cycle equals to T on divided by T. Duty cycle. Duty cycle describes the proportion of on-time to the regular interval or period of time stated by Bart 2019. The duty cycle represents the amount of time in waveform spent in height or on-time state relative to the time in the one complete cycle. Duty cycle equals to time on time divided by turn on time plus turn off time. The output path width can be lengthened or shortened to the need of the specific application by adjusting the value of R and C. Figure 5 shows the duty cycle. The first figure is for 15% duty cycle. The second figure for 75 duty cycle and the third figure for 25 duty cycle. Methodology. The figure shows the pin diagram of LM555 IC timer. Pin number 1 is connected to ground pin, pin 2 for trigger, pin 3, output pin 4 flip-flop circuit, pin 5 connected to the inverting input, pin 7 connected to the open collector, and pin 8 connected to the positive supply voltage. Figure 7 shows the internet schematic of LM555 IC timer. From MOIT 2017, the internal schematic of LM555 IC comprised of two op-amp comparators, a SR flip-flop, a reset transistor, discharge transistor, and three identical transistors and an output stage, and lastly voltage divider network. How past position modulation signal is operated. Past position modulation can be operated by combination of stable and monostable configuration as shown figure in below. For stable mode operation, the modulating signal input of 1 kHz 2 V peak-to-peak is applied to the control terminal pin 5 of the stable stage. For generate past position modulation at monostable mode, its output pin 3 is connected to the input pin 2 of the monostable stage in which its output gives past position modulated signal. The output past position changes with the modulating signal since the threshold voltage and hence the time decay is changed. It can observe from the output that the frequency changing during the past position modulation. Result and discussion. The figure show the simulation circuit schematic using NI Multisym version 14. Observation. There are two observations we take from this simulation. The first one is the output of PWM waveform in the form of pathways was observed from pin 3 of the first LM555 IC timer. And the second observation was take the output of PPM waveform in the form of pathways was observed from pin 3 of the second LM555 IC, shown in table below. For the input, modulating signal used is frequency equals to 1 kHz and amplitude of the input is 2 V peak-to-peak. Secondly, output of a stable configuration. A pass rate of amplitude equal to 5 V peak-to-peak and the frequency is equals to 1 kHz. The observation of output monostable configuration for PPM modulating signal. The frequency is equals to 1 kHz and amplitude is equal to 2 volt peak to peak. Result for ppm circuit summation for RA equals to 2.2 kilo ohm and RB is equal to 3.9 kilo ohm, while R1 equals to 1.8 kilo ohm. From the theoretical or by calculating, T high is equal to 42.27 millisecond, T low is equal to 15.25 millisecond, and the duty cycle T high plus T low is 57.52 millisecond, and the duty cycle for the ppm signal is equal to 73.4%. When we are using NI Multisym version 40, the duty cycle measure is equals to 70.0%. Table 3 show the result of ppm circuit with RA equals to 2.2 kilo ohm and RB equals to 3.9 kilo ohm, while R1 is equal to 1.8 kilo ohm. By theoretical value or by calculating when RA less than RB. So the percentage of duty cycle equals to 61%. When we are using NI version 14, the percentage of duty cycle was equals to 57%. Conclusion. First, this research is to study the implementation of ppm modulation circuit design techniques using the LM555 timer IC. Second, the LM555 is a popular and versatile integrated circuit used in various generation applications. Third, the two configurations of LM555 timer used to generate ppm modulator were a stable mode multivibrator and monostable mode vibrator. Fourth, in stable mode multivibrator configuration, the LM555 timer is used to produce a continuous square wave output or PWM signal. Fifth, monostable multivibrator in this configuration is set up to produce a single output pulse or PPM signal. Sixth, observing the result using NI Multisym version 14 simulation package, PPM modulation technique can be effectively implemented using very simple circuit by combining the two LM555 IC timer. That's all for research presentation today. Thank you.